Hello, my dear students. Welcome to the second session on the polarity of bonds or dipole moment or polarity of bonds. Okay. Yesterday or in our previous class, we discussed it is because of electronegativity poles are created and two poles are created, and this is known as what? Dipole moment. And the same dipole moment is, in another word, it is called as what? Polarity of bonds. Now today we will continue the polarity of bonds chapter once again in the today's session. So once again I welcome you all for the today's session. Electronegativity and the bond polarity, these two relation. We can use the difference in electronegativity between two atoms to gauge the polarity of the bonding between them. That means by knowing the difference in the electronegativity of the two atoms in a molecule, we can tell that whether it is a polar or non-polar. First point, in that if it is polar, how much polar, or if it is covalent, how much ionic character, or if it is ionic, how much covalent character starts developing. So all those information we will get from this topic known as what? Electronegativity and bond polarity. See, here is an example. F2 fluorine molecule, hydrogen fluoride, lithium fluoride. Okay, here this is the combination of two similar atoms. This is the combination of two different atoms. Here also different atoms, but difference is here both are covalent. Here one is covalent. Both are electronegative. But in this case, one is most electronegative, one is least electronegative. So he has taken three different situations, and here he has compared electronegativity difference. One is fluorine, other is fluorine. Difference is what? 0. Okay. When the electronegativity difference is 0, poles are not created. So it is a non-polar covalent. Now, difference between H and F equal to 1.9. That time, so that means difference is there. Poles are created. Therefore, this is covalent, but it is a polar covalent. This is non-polar covalent. This is polar covalent. Non-polar covalent when there is no withdrawal of shared pair of electrons. Polar covalent when they withdraw shared pair of electrons due to a difference in the electronegativity. Whereas in the case of lithium fluoride, you see difference is more. When the difference in the electronegativity is more, then it develops the ionic character. So it is ionic compound. So these three are beautiful examples to know that which is more covalent, which is non-polar, which is polar, and which is covalent bond having the more ionic character. All these examples you will come to know from the knowledge of electronegativity and bond polarity. Same thing as told here in terms of explanation. I leave to you. Okay. The sharing of electrons in HF is unequal. The fluorine atom attracts electron density away from the hydrogen because it is more electronegative. The bond is thus a polar covalent bond. The HF bond can thus be represented as, see, this is the arrow mark indicating that electronic flow is there from hydrogen towards the fluorine, because fluorine is the most electronegative. It withdraws the shared pair of electrons, making itself partial negative, and it is losing, so it is not losing that like a ionic bond. Here electron cloud lies near fluorine than hydrogen. That means partially H is losing, F is gaining. So because of gaining electronic cloud, it gets partial negative charge, and because of losing electronic cloud, it gets the partial positive charge. That is the idea behind this bond polarity. The D plus D minus symbols indicate partial positive and partial negative charge. This is called, in some book it is called delta. Now here it is called D, delta positive, delta negative, both are correct. The arrow indicates the pull of electrons, the hydrogen, and towards the more electronegative. This I told already. Okay. In lithium fluoride, the much greater relative electronegativity of the fluorine atom completely strips the electron from the lithium, and the result is an ionic bond. So in the case of lithium fluoride, because of more difference in the electronegativity, fluorine actually snatches electron from the lithium. It is not a sharing, it is a snatching or transfer of electron from lithium to the fluorine, thus going for the ionic bond, not the covalent bond. If both are sharing, covalent. If one is snatching or transfer, it is ionic. This is a point you have to remember in a bond polarity. Now we will go for a general rule, okay, for predicting the type of bond based upon electronegativity difference. If the electronegativities are equal, that is, if the electronegativity difference is 0, the bond is non-polar covalent. Formula or the rule. If the difference in electronegativities between the two atoms is greater than 0 but less than 2, the bond is polar. Okay. And third rule is what? If the difference in electronegativities between the two atoms is either 0 or either 2 or greater than 2, then the bond is called ionic. So depend upon the difference in the electronegativity, you can decide this bond is whether it is a non-polar covalent or polar covalent or ionic. So this is a very useful information we will get from the difference in the electronegativity. The property of shared pair of electrons being closer to one atom than the other in a covalent bond is called bond polarity. Okay, I have told in the beginning only on a cartoon where HCl was there, Cl was more electronegative, it was holding electron more strongly towards itself, creating the pores, and this is called once again bond polarity. This is the definition for the bond polarity. As a result of polarization, what is polarization? Here electrons are polarized from one atom to the other atom. Okay, so this is called what? Polarization. See, we use this word in the election also. So results are polarized. Okay, because of influence of a particular person, or because of influence of the area or of the party or the work he has done it. So we expect some party, but some other party will come, and after the result we analyze. So this is because of what? Polarization of the votes due to that person, irrespective of the party. So that is the meaning of what? Polarization. So here, what is polarizing? It is electronic cloud is polarizing. That is a meaning of polarization in chemistry, especially in the bond polarity. So as a result of polarization, the molecule possesses the dipole moment, which can be defined as the product of the magnitude of the charge and the distance between the centers of positive and negative charge. So here he has given one more definition for the dipole moment. So for a short while, for a short period of time, two poles are created. Dipole moment. What is the dipole moment? It is the product of charge and the distance of the two, that is positive and the negative end. If you calculate using the physics knowledge, in physics there is an instrument device known as polarimeter. So using the polarimeter, you note down the charge on the two atoms and the distance between the two atoms. If you multiply these two, that is the dipole moment of that molecule, which you are going to learn in the higher class. This dipole moment is designated by the Greek letter mu, symbolically this one. Same symbol we use for almost for the refractive index of a material, especially of the prism. See, formula: dipole moment equal to, or mu equal to, charge into distance of separation, q into r. And the dipole moment is measured in unit known as what? Debye units. Debye is the scientist, Peter Debye. He has done the research work on the dipole moment. So he has made the unit, therefore his name is kept for the dipole moment. So dipole moment is measured and expressed in what unit? In the Debye units, symbolically D. And the conversion factor CF is 1 Debye. is equal to 3.33564 into 10 to the power minus 30 cm. C for coulombs, M for meters. Meter, distance of separation. Coulomb for the charge he has taken. Further, dipole moment is a vector quantity. Once again, physics knowledge. A quantity which has a direction and the magnitude is called vector quantity, because dipole moment has both magnitude and the direction, therefore it is vector quantity. And by convention, it is depicted by a small arrow with tail on the negative center and head pointing towards the positive center. But in chemistry, presence of dipole moment is represented by the crossed arrow like this put on the Lewis structure of the molecule. The cross is on positive end and arrowhead is on negative end. This is what we represent like this. For example, the dipole moment of HF may be represented as, this is the symbolic way of representing the movement of electrons. So this is the loss of electron plus this is the movement of electron getting the partial negative charge. This arrow symbolizes the direction of the shift of electron density in the molecule. Note that the direction of crossed arrow is opposite to the conventional direction of dipole moment vector. In case of polyatomic molecules, the dipole moment not only depend upon the individual dipole moments of bonds known as bond dipoles, but also on the spatial arrangement of various bonds in the molecule. That means the dipole moment in the case of polyatomic. What is polyatomic? Molecule having more than 2, 3, 4. They are called as polyatomic. Ammonia, methane, they are called polyatomic molecules. In those polyatomic molecules, dipole moment depends upon not only the sharing of electrons or the electronegative difference, but also depends upon the spatial arrangement of the electrons around the nucleus or the structure. That means it is a structure determines. It is also one of the factors that is the cause for the dipole moment. In such case, the dipole moment of a molecule is the vector sum of the dipole moments of various bonds. That time, how to calculate? That time it is calculated vector sum of all the dipole moments of the bonds. Not clear? With example, we will make it clear. Okay. Now, time being, we will take a short break, and in our next class, with example, we will discuss how this dipole moment is used, how the structure is used to calculate and to tell the dipole moment of a molecule. Thank you, my dear boys.